Good morning, class. Here's exam 3 review, chapter 3, differentiation rules, chapter 4, application of differentiations. And in this case, we are covering section 3.10, linear approximation and differentials, 3.11, hyperbolic functions. So 3.10, section 310, differentials and linear approximation. Here's the definition for y equals f of x. We define dx called the differential of x by dx equals delta y. In other words, if we look at this graph, dx or delta x or this distance bp is the run. If you have a curve and you have 2 points, this distance, the run is delta x or dx. This is delta x, everybody. And so dy is defined as follows. Dy called the differential of y is dy equals f prime of x dx. Recall f prime of x is dy dx. So if you treat this as a fraction, the product, cross product will result in dy being f prime of x dx. Now, take a look at the graph. Delta y is rise along the curve. Therefore, it's equal to this distance, which is BQ, which is f of x plus delta x minus f of x. This distance is the f of x plus delta x, which is CQ minus f of x, which is PD. And it gives us this distance of BQ, also known as delta y. dy, which we found it to be f prime of x dx, is the rise along the tangent line. So take a look. This distance, as we go from this point to this point, this distance AB is dy. This distance BQ is delta y. The two are not the same. But the closer the value of delta x to 0, the better approximation of these two. In other words, delta y is approximated by dy. So delta y is precisely equal to f of x plus delta x minus f of x. We can replace delta y by dy for a function f, which is a continuous and differentiable function with a small delta x, if delta y is difficult to evaluate. In which case, we know f prime of x is dy dx. We can approximate it by delta y delta x. And therefore, delta y would be the product of these two. By the way, f prime of x times delta x or dx makes no difference because delta x and dx are identical, everybody. They are identical. So, over here, delta y is f of x plus delta x minus f of x. F of x plus delta x is f of x plus delta y. F prime of x is dy dx, which results in dy being f prime of x dx. And over here, f of x plus delta x, which is f of x plus delta y, we're going to change the delta y to dy. If we call this point with coordinates a and f of a, linearization refers to finding the tangent line. You already know how to find the tangent line. And we're going to use the point slope, y minus y1 equals m times x minus x of 1. Okay. And so if you move the y sub 1 to the other side, becomes this one. Now m is f prime of a, x sub 1 is a, and y sub 1 is f of a. Do I have, and we change the y to L of x. Do I have to memorize that? No, just remember the point slope. That's all we need. Let's move on, everybody. For y equals 4 minus x quantity cubed, find dy. Well, the moment you hear dy, ignore that and find f prime or dy dx, which means you're going to differentiate this using the product rule. F prime g plus g prime f. So the derivative of x is 1 times 4 minus x quantity cubed. Then the derivative of g, or 4 minus x cubed, is 3 times 4 minus x squared times the derivative of the inside, which is -1. So one more time, 3. Same parenthesis, the power of 3 minus 1 or 2. And then the derivative of the inside, this is by the chain rule. And now times f times x. And I'm going to write at top of it f prime g plus g prime. Now we can factor 4 minus x. This one has exponent 3. This one has exponent 2. We're going to go with the exponent 2. When we do that, this one gives us 4 minus x. This one gives us 3 and -1 and x, which is minus 3x. Minus x and minus 3x, they combine into minus 4x. We can leave it as that, or we can take the -4 out here in the second parentheses. I can change this to -4 times x minus 1. And I put the -4 in front. Now, part B says find dy and delta y when x is 5 and dx or delta x is 0.2. Therefore, we are first going to find dy, which is the same thing times dx. Now we're going to replace the x with 5 and dx with 0.2. This is -1 squared becomes 1, and this is 4. So we have -4 times 4, which is -16, times 0.2, which is -3.2. Now for delta y, we are going to find delta y as f of x plus delta x minus f of x. So f of 5.2, because x is 5, delta x is 0.2, f of 5.2 minus f of 5. And at this point, you plug in 5.2 here, original function y or f of x. You plug in 5 in here and leave it for you to evaluate. Minus 8.64 plus 5 is minus 3.64. And as you can see, delta y, which is -3.64, is pretty close to dy, which is -3.2. Of course, the smaller the value of delta x compared to the value of x, the closer the value of delta y and dy must be. differentiate y equals ln of sine theta, and you recall for natural log, you flip this over. So y prime is 1 over sine theta, and by the chain rule times the derivative of sine, which is cosine, and that is cotangent theta. Y equals e to the power of x over 1 plus x, and we want to find the derivative. We're going to use the quotient rule. This is f over g. So we use f prime g minus g prime f over g squared. So the derivative of the top is e to the power of x times the bottom, which is 1 plus x, minus the derivative of the bottom is 1 times the top, which is e to the power of x. And now g squared, just write this in a parenthesis and square. So what you're looking at is f prime you're looking at f prime g minus g prime f over g squared, and we are going to distribute, get e to the power of x, the power of x times x, minus e to the power of x. These two cancel each other. And we put the x in front. We end up with x e to the power of x over 1 plus x quantity squared. Now, let's find the differential of each function. All you have to do, remember that dy is f prime of x dx. So in this case, dy is this one times d theta, because the independent variable is not x, okay, d theta. For this one, dy is the same thing times dx. So you've done the hard part, okay? That's the idea, everybody. Use differentials to approximate 51 squared. Just reminding you of what you learned in algebra. Perhaps they have gone over this, that if you want to square that, you write as 50 plus 1 squared, which is, of course, you should do it in your head, 50 squared plus 2 times 50 times 1 plus 1 squared, which is 2601. So you should be able to do that in your head. But using the differential means the following, everybody. Number one, we have to find a function that represents this operation. And it's easy to figure it out. It says 51 squared. The operation is the operation of squaring, so therefore we let f of x be x squared. Part two, choose a number x close to 51 for which squaring is easy to compute. That number is obviously 50 because everybody should know 50 squared is 2500. So what is delta x or dx? We are going to go from 50 to 51. So from 50 squared, we're going to go up to 51 squared by 1. So the difference of 51 and 50 is positive 1. I can't emphasize this enough. As an example, if we were interested in finding 48 squared and using exactly the same thing here, then delta x or dx would be -2. So it is extremely important that we pay attention to this concept. All right, so what do we have? F of x plus delta x is f of x plus dy, and we have f of x, which is x squared. We need to find dy, which means we need to differentiate this first. F prime of x or dy dx is 2x. Therefore, dy is 2x dx. I'm going to need this space. And so f of x is replaced by x squared, dy is replaced by 2x dx. Now we are ready to finish the job. We want 51 squared, or f of 51, f of 50 plus 1. In other words, x is 50 and dx or delta x is 1. So we put in here x equals 50 and dx equals 1. When we do that, this is 50 squared, 2500 is 2 times 50 times 1, 2x dx, which is 100, makes it 2600. And as it was mentioned, 51 squared is 2601. And see how close they are. And the reason they are fairly close, because 1 compared to 50 is pretty small, dx compared to x. Now, what I want to go over, so this is the synopsis of what we have done. What I want to go over is reminding you of the linearization. So that will result in the same thing as long as you find the tangent line. You call it L of x at the end, but just you have to find the tangent line. To do that, you need two things. You need the function. Well, the function is f of x equals x squared, and you need a pair. So at what point? At x equals 50. Now at x equals 50, the pair is 50, comma 2500. So you want to find L of x at the pair 50, comma 2500 with the slope being 100. Why is the slope 100? Because remember, f prime of x, if you replace the x with the value, becomes the slope of a tangent line at that point. So f prime of x is 2x. 2 times 50 results in 100. Now we want to find L of x. We're going to go with the point slope, y minus y1. That means y minus 2500 equals n 100. X minus x of 1, x minus 50. And if you do the math, move things around, it's of course 100x minus 5000. We are going to add 24,500 to both sides. L of x, which means the tangent line is 100x minus 2500. What do we want? We want L of 51. L of 51, if you replace the x with 51, gives you the same. This is 100 times 51 minus 2500. You do the math, gives you 2600. These two numbers must be identical because differentials and linearization, they will result exactly in the same answer. Okay, everybody? They will result in the same answer. Let's look at a similar question. We want to use differentials to approximate cube root of 63.5. We're going to go through the same process. Number one, we want a function. So how do we find the function? Just read the question. What is the operation? Cube root of 63.5. So cube root of something, cube root of x. Number 2, choose an x to be a number close to 63.5 for which the cube root is easy to compute. So clearly it would be 64 because everybody knows that cube root of 64 is 4. So pretty straightforward so far. Now, we are going to go from 64 to 63.5. So delta x is 63.5 minus 64, which makes it negative 0.5. Meaning, we know cube root of 64 is 4, whatever the number may be. Cube root of 63.5 must be less than 4. Whereas if we were interested in cube root of 65, for the sake of argument, if we wanted cube root of 65, then delta x or dx is positive 1. Because 65 minus 64, 65 minus 64 is positive 1. Meaning, cube root of 65, we don't know it, but for sure is larger than the cube root of 64, which is 4. That's the idea, everybody. And so having said that, we know that this is f of x. So we are going to differentiate that. We are going to differentiate that because for f of x plus delta x, we need f of x plus dy. And to find dy first, we need to find f prime of x. So f of x, we change it to x to the power of 1/3. To differentiate this, we get 1/3, x to the power of 1/3 minus 1 or negative 2/3. If we bring this down, it becomes x to the power of positive 2/3 or cube root of x quantity squared. So this and this is just the algebraic operation. We should be fine with that. So that's f prime of x. What is dy is the same thing times dx. So you multiply this one by dx. And therefore, the function f of x plus delta x is the function f of x, which is cube root of x, plus dy, which is dx over 3 cube root of x quantity squared. So what is the cube root of 63.5 is f of 63.5, which makes it f of 64 plus dx or delta x, which is negative 0.5. So these are the two functions. This is the function, this is dy. And we want cube root of 63.5, which is f of 63.5, which means f of 64 plus negative 0.5, meaning x here and here is replaced by 64 dx by negative 0.5. So let's plug in. Now, cube root of 64, we know it to be 4. So that's not a problem. So that is replaced by 4. This is replaced by 4. And therefore, what we are looking at, this is 4, everybody. This is minus 0.5. I'm going to change it to 1/2 over 4 squared is 16 times 3 is 48. So this is negative 1/2 over 48. It's a complex fraction. We multiply the denominator by 2, becomes negative 1 over 96. 4 minus 1 over 96 makes it 3 and 95 over 96. And of course, if you want to go with the approximation using a decimal, you can do so. Notice, let me erase everything so we can notice the calculator gives you that answer, and 1, 2, 3, 4 decimals are the same. And if you want to stop here, you change the 5 to 6 because of this one. The same thing here. So these 4 are identical, and then it continues. Here's the reason. The numbers are extremely close because delta x or dx is extremely small compared to the choice of x. So that's why the approximation is very good. Now, we're done. However, we can do linearization. Again, we can do tangent line. And basically, I'm going to stick with this point slope, which means in order for me to find the tangent line, what is my function? F of x is cube root of x. What is my point at x equals 64? So I want the tangent line for f of x equals cube root of x at x equals 64. Or you can say just L of x. So to find that, we need two things. We need a pair. So 64, if you plug in, you get 4. So 64 comma 4 is the pair. We need the slope. We put it into f prime of x. Here's f prime of x. If I put 64 here, I get 4 squared. 16 times 3, 48. So 1 over 48 is the slope. So plug this into f prime of x. M equals f prime of 64. So going through the process, y minus y1 equals m times x minus x sub 1. So y minus 4 equals 1 over 48 times x minus 64. And I let you finish the job. L of x or y becomes 1 over 48 times x plus 8/3. Now, if you replace this x with 63.5, you get precisely what we have here. I'm going to leave it for you to finish the job. For y equals f of x equals sine x, find dy. Well, the moment you hear dy, ignore it. Find f prime of x. So we're going to find f prime of x, which is dy dx, and that's cosine x. So what is dy? The same thing, times dx. Find its linearization at pi over 6, meaning find the equation of a tangent line. So for this function, to find the equation of a tangent line, we need two things. We need a pair, and we need the slope. Well, the slope is cosine x, so cosine of pi over 6, which is square root of 3 over 2. We should know that. It's a common arc. And the pair has coordinates x and sine x. X and sine x. X is pi over 6, and sine of pi over 6 is 1/2. So pi over 6 and 1/2. So hopefully everybody's comfortable with that. So y minus y1 equals m times x minus x of 1, which means y minus 1/2 equals m square root of 3 halves x minus pi over 6. You're going to work with pi. You want to keep it as pi. You want to come up with the exact answer. So this remains, and you move the negative 1/2, you make it positive 1/2 on the right side, meaning L of x or y is square root of 3 over 2 times x. Now multiplying these two, you get square root of 3 pi minus square root of 3 pi over 12 and 1/2. Please bear in mind, this is a number. So you can, if you put it into a calculator with a bunch of decimals, you see this is just some number. Because pi is an irrational number, we keep it as pi. So we found the linearization at pi over 6. Approximate sine of 31 degrees. And in other words, what is sine of 31 degrees? We're going to do it two ways. Before we do that, I'm going to remind you that 30 degrees means pi over 6. I hope everybody remembers that. So pi over 6 means 30 degrees, right? And since we found this using pi over 6, we're going to stick with that. So we have to change the 31 degrees in a format which is 30 plus 1 degree. 30 degrees plus 1. This is 30 plus 1. Now, 30 means pi over 6, 1 means pi over 180. So sine of 31 degrees is sine of 30 degrees, which is pi over 6, plus 1 degree, which is pi over 180. And now we are going to use the differentials, which is f of x plus delta x is f of x plus dy. And f of x, you want sine of that, it's sine x. F of x is sine x. What is dy? Cosine x dx. So again, f of x, sine x, dy, cosine x dx. And now, what is x? Pi over 6. What is dx? Pi over 180. Put it in here. So sine of pi over 6 plus cosine of pi over 6 times pi over 180. We know these values. This is 1/2. This is square root of 3 over 2. I have to put this into calculator times pi over 180 with a bunch of decimals. When you do that, you end up with 0.515. So this is one way to do it. We use the differential. Now we're going to use linearization, or the tangent line that we found here. So y or L of x is found, but what is x? 31 degrees. What is 31 degrees in radians? 31 pi over 180. So L of x means L of 31 pi over 180. Replace the x with 31 pi over 180. You have to use a calculator at this point, because 31 pi over 180, put it into a calculator, that times square root of 3 over 2 minus square root of 3 pi over 12 plus 1/2. When you do the math, again, if you keep tons of decimals, you end up having with the first 4 decimals, they are identical. Okay, it's important that you come up with the same answer, because linearization, which is finding the tangent line, and differentials, which means f of x plus delta x is f of x plus dy, they must give you the same answer. One side of a right triangle is known to be 20 centimeters long, and the opposite angle is measured as 30 degrees. With a possible error of plus minus 1 degree, use differentials to estimate the error in computing the length of the hypotenuse. What is the percent or percentage error. Let's do the drawing. So we have the angle here is theta. This is a right triangle. This is 20 centimeters long. And this is 30 degrees because it's opposite that, with a possible error of plus minus 1 degrees. So one leg is 20. The opposite angle 30 is, theta is 30 degrees. And this means what? Possible error. D theta. The possible error in theta is delta theta or d theta, plus minus 1 degrees, which is plus minus pi over 180. And we want to use the differential to estimate the error in computing the length of the hypotenuse. So we want the error in the hypotenuse, we want dx. Therefore, we write, given one leg equals 20 centimeters, opposite angle theta is 30 degrees, with a possible error of plus minus 1 degrees d theta, which makes it plus minus pi over 180. And we want part A, use differential to estimate the error in computing the length of hypotenuse. The error in that would be dx. Now, we want to relate the two quantities, and that means what is given and what is missing. We want to relate the theta with x, and we know that sine of theta is the opposite 20 over x. Cosine theta is adjacent, which we don't have to x, so we're going to go with sine theta is 20 over x. So if we do the cross product, okay, we see that 20 is x times sine theta. And if we want to find x, we can divide by sine theta. If we divide by sine theta, that means x is 20 cosecant theta, because 1 over sine is cosecant. And now we can differentiate. We can find dx d theta, dx d theta. So we're going to find dx d theta, 20 times cosecant gives us negative cosecant cotangent. So 20 remains. Cosecant gives us negative cosecant theta, cotangent theta. And therefore, dx is the right side times d theta. Now, of course, we are going to replace the theta with 30 degrees. So minus 20, cosecant 30 degrees, cotangent 30 degrees, and d theta is plus minus pi over 180. So if you replace this theta with 30 degrees, cosecant is a 2, because cosecant is 1 over sine. Sine of the 30 degrees is 1/2, and cosecant 30 degrees is the reciprocal of that, which is 2. Cotangent, you should know it to be square root of 3. So dx therefore becomes, again, a piece of information from trigonometry, minus 20 cosecant of 30 degrees. Maybe I write it in this fashion. Let me. So minus 20 cosecant of 30 degrees, or pi over 6, cotangent of times 30 degrees over pi over 6 times d theta plus minus pi over 180. And now if you put it into a calculator, it gives you plus minus 2 square root of 3 pi over 9. This, of course, not a calculator yet. If you put this into a calculator, it gives you plus minus 1.21, and the units of the length, centimeters, plus minus 1.21. Now, they might ask you how many decimals, you do it accordingly. So simplification of this gives us plus minus 2 square root of 3 pi over 9. Relative error is the ratio of dx to x. Well, you can use this number for dx, and for x is 20 cosecant theta. We said cosecant theta is 2, which makes it 2 times 20, 40. Or just let's write out the dx, which is this. And the bottom is 20 times 2, as I mentioned, is because x is 20 cosecant theta, everybody. 20 cosecant theta. And so we can see these two cancel out these two. And we get plus minus square root of 3 pi over 180. And now if you use a calculator, you get plus minus 0.03 or plus minus 3%. So that would be the relative error. Hyperbolic functions. Let me remind you of some basic stuff we have seen. Unit circle, x squared plus y squared equals 1. Therefore, cosine squared plus sine squared equals 1. Hyperbola, x squared minus y squared equals 1. Therefore, cos squared minus sin squared equals 1. That's why it's called hyperbolic functions. And as far as the definition of hyperbolics is concerned, cos x or hyperbolic cosine is e to the power of x plus e to the power minus x divided by 2. Sin x or hyperbolic sine is e to the power of x minus e to the power minus x over 2. So we hopefully remember this stuff from previous courses. And now hyperbolic identities were discussed before. For example, cos squared minus sin squared equals 1. You remember sine squared plus cosine squared is 1. So they are similar, but they are not exactly the same. Hyperbolic cotangent squared minus 1 is equal to hyperbolic cosecant squared, and 1 minus hyperbolic tan squared is equal to hyperbolic secant squared. So they are similar to that. Sin 2x is 2 sin x cos x. Cos 2x is cos squared plus sin squared. Whereas, for example, cosine 2x was cosine squared minus sine squared. Cos squared becomes cos 2x plus 1 divided by 2. Sin squared is cos 2x minus 1 divided by 2. If you remember, tangent was sine over cosine. So hyperbolic tangent is sin over cos. Hyperbolic cotangent is cos over sin. Hyperbolic cosecant is 1 over sin, and hyperbolic secant is 1 over cos. This is very similar to trigonometric functions. For example, tan x is sine x over cosine x. Now, sin of minus x is minus sin x, so that is an odd function. Cos of minus x is cos x. This is just like sine and cosine. If you remember, sine of minus x is minus sine x, but cosine of minus x is cosine x because it's an even function. So we have similar identity. Sinh of x plus y is sinh x cosh y plus cosh x sinh y. Cosh of x plus y is cosh x cosh y plus sinh x sinh y. This is slightly different, but this is similar. Sine of alpha plus beta was sine alpha cosine beta plus cosine alpha sine beta. So it's very similar to trigonometric functions, but there are some differences. When you want to differentiate, the derivative of sine is cosine, the derivative of cosine is negative sine. However, the derivative of sinh is cosh, the derivative of cosh is sinh, and so forth. So we have some hyperbolic derivatives here. The inverse hyperbolic functions, because hyperbolic functions are defined as a function of e to the power of x, then they are natural logs. For example, sinh inverse is ln of x plus the square root of x squared plus 1, and so on and so forth. Now, how do you differentiate this? If you recall, for trigonometric functions, for inverse trigonometric functions, for example, the derivative of sine inverse was 1 equals 1 over 1 square root of 1 minus x squared. Cosine inverse was the same thing with the negative sign. Tan inverse was 1 over 1 plus x squared. For cotangent inverse was the same thing with the negative sign. Now, similar answers are here. The derivative of sinh inverse is 1 over square root of x squared plus 1. For cosh inverse is 1 over square root of x squared minus 1. And for hyperbolic tan inverse, 1 over 1 minus x squared, similar to that. So these are some formulas from hyperbolic functions. So what we want to do, we want to start with proving some of this stuff. For example, we want to prove the identity cosh squared minus sinh squared equals 1, and we go using the definition. We know cosh x is e to the power of x plus e to the power minus x over 2. Sinh x is e to the power of x minus e to the power minus x divided by 2. And that's exactly what we are going to do. We are going to replace the cosh and sinh with what we have here. So cosh would be this one. Now raise it to the power of 2. Minus sinh would be this one. Raise it to the power of 2. That would be the left-hand side. Normally, when we did the trigonometric identities, we started with the more complicated side. The left side is more complicated. And we are going to raise each one to the power of 2. And I hope you remember how to do that. So when we raise this to the power of 2, the denominator in both cases becomes 4. This becomes e to the power of 2x. This becomes 2 e to the power of x times e to the power minus x plus e to the power of minus 2x. This becomes the same thing with the negative in between. So I hope you realize that this is really 1, so we have 2 here, and therefore negative 2 over there. So if we were to write this out, denominator is 4 e to the power of 2x plus 2 plus e to the power minus 2x. We're going to apply the negative sign, minus e to the power of 2x plus 4 minus e to the power minus 2x. So I hope you see that this is plus 2y there. So everything cancel out. That means these 2. That means these 2, except 2 and 2, they add up to 4. 4 over 4 is 1. So that's a proof. We went from one side to the other. We want to prove that 1 minus hyperbolic tangent squared equals hyperbolic secant squared. We did this type of proof in trigonometry. We started with what we know already. So we already have this. So we're going to start with cosh squared minus sinh squared equals 1. Since we want this one to be 1, we're going to divide everything by cosh squared to make this one 1. So we divide both sides by cosh squared. This is 1 minus hyperbolic tangent squared. 1 over cosh is hyperbolic secant. So 1 over cosh squared is hyperbolic secant squared. That's the proof. We want to differentiate, take the derivative of sinh 10x squared. If you recall, I said when you want to differentiate trigonometric functions, just read sine and stop. In this case, we're going to read sinh and we stop. The derivative of sinh is cosh. But just like trigonometric functions, we have to use whatever the argument is. So we need to put 10x squared. And then the chain rule says, now take the derivative of 10x squared and multiply by it, which is 20x. This is by the chain rule, everybody. And we are going to rewrite it by putting 20x in front. d dx of cosh x. So we know we're going to stop at cosh. And we know the answer is sinh. So we're going to write sinh. So what happens next? We have to have an argument. So we have to have square root of x. We also have to use the chain rule and differentiate this. As you know, this is x to the power of 1/2. Its derivative is 1/2. X to the power of negative 1/2 or 1 over 2 square root of x. And so it's sinh square root of x over 2 square root of x. F of x is tang or hyperbolic tangent of 1 plus e to the power of 2x. So we're going to look here. Hyperbolic secant squared. So hyperbolic secant squared. But you have to use the same argument. 1 plus e to the power of 2x. And now by the chain rule, you are going to differentiate the argument 1 plus e to the power of 2x, which becomes e to the power of 2x times 2. We're going to rewrite it, and we are done. y equals sinh inverse of x squared. Sinh inverse is 1 over square root of x squared plus 1. However, what if we don't have x, rather we have a function of x as it is the case here? Then we call this u, everybody. And this becomes u, and the numerator becomes du dx. Please understand, when it's a function of x, you use u, du dx. And the same thing for the rest of it. You can change the u to g of x if you want, g prime of x. And so, having said that, we're going to write it in this fashion. Now, this has to be squared. This gets squared according to this, or you can even say this. So you get x to the power of 4 here. By the chain rule, I need to multiply by the derivative of x squared, which is 2x. And I just rewrite this. How about y equals sinh inverse of tan x? We do exactly the same thing. Like here, we write it in this fashion. This one is whatever this function is squared. So squared is put it here. And by the chain rule, we need the derivative of that, which is secant squared. I just rewrite it. So it's secant squared x over. Now, tan squared plus 1, I hope you remember, is secant squared. And this is actually absolute value of secant x. When you divide the top by the bottom, it remains as an absolute value because we don't know if it's going to be positive or negative, okay? Y is equal to e to the power of x times cos x. I put a raised dot in between and I say f times g, and the derivative is f prime g plus g prime f, the product rule. So e to the power of x is itself times the second piece cos x plus cos, the derivative is sinh. Remember, it's not negative, okay? It's just the derivative of cosine, which is negative sine x, but cos is positive sinh times e to the power of x. We're done with calculus. We factor e to the power of x out. Now, if you left it as that, it's sort of okay, but I hope you can see the following. Going back to the definitions, if we add sinh and cos, what do we get? E to the power of x plus e to the power of minus x plus e to the power of x minus e to the power of minus x, and all of them divided by 2. If you add these two, this e to the power of minus x with minus e to the power of minus x cancel each other. You get 2 e to the power of x over 2, which is e to the power of x. And then e to the power of x times e to the power of x is e to the power of 2x, everybody.